has an open TCP connection or two to Google for your messages, for your Gmail, etc. So that means, right now we probably have, 1-2 billion active TCP connections from these devices. And, 5 years ago that would have been a problem, right? Because we didn't need that and we hadn't built the infrastructure to do it. Today it's not a problem, and if it goes from 1 to 2 or from 2 to 4, I don't think that will cause us to do much, because it's, usually a factor of 10 is sort of reasonably easy, and then beyond that you have to do real work.
All right. And I want to ask too, Google is kind of like, Facebook was out here this morning, right? And Jay talked about they built this network switch, and Google has been building servers and, from what I understand, switches and chips and all these things for a long time. Is there a point at this point where Google where its workloads could handle going back to, commercial stuff? Is that ever even a realistic option?
Yeah, I think actually in the long term, so, if you back up, very much in the beginning we were doing hardware just to save money. So you replace the integration piece, you replace the margin of a white box kind of thing. Then we were doing hardware, and we still are, because our use case really was diverging from what a typical server vendor actually was able to satisfy. Because we were thinking much more about, the data center as a computer rather than a single box as a computer, and that really pushes you in a different place. I think with cloud, these things actually in the 5-10 year frame actually converge again, because normal quote-unquote workloads, not just Google scale workloads, are going to run on the same infrastructure and therefore can use the same hardware pretty much. Right. And so it's actually going to be, I think, a long-term arch that will really converge these things.
All right. And you mentioned this idea of like a data center scale system, right? Mm-hmm. And I think, if people have been following the last couple of weeks, right? So last week you announced this whatever it's called, Kubernetes or something, but
Kubernetes.
I kind of envision it as so let me just back up. I'll stop it, sorry. But so the one thing, Google has been doing for a long time, right, is building, these data center scale operating systems, so to speak, right, the Borgs and the Omegas. Can you just talk about, for, I guess, the unfamiliar with how that's conceived?
Sure. Many people focus on data centers as a physical thing. Like, here's a building and it's filled with these rows and rows of computers, and of course that's what they are, and there's lots of challenges there. But the bigger challenge is actually, how do you make that useful, and how do you make it easy to use to a programmer who doesn't really need to know about all these details? And so one of the key pieces is the cluster management that takes a stream of workloads from multiple users and then actually places it on these servers and networks and clusters, et cetera, et cetera. And what we did, and so internally, we've been actually using for the last 10 plus years, not VMs to manage a multi-tenant workload, but this thing called containers. Basically same idea. It allows you to put a workload sort of in a box, different trade-offs. And so you need a scheduler, a manager that actually takes your different workloads, the Gmails and the searches and the ads and the news.google.com, and puts them inside the cluster. What we did last week is we open sourced a simplified cluster manager, so to speak, for Docker images that allows you to do it in a smaller scale, that allows you to do the same thing. So you have a set of VMs, and you put one or more of these containers inside a VM in order to run them. And so that lets you think about your application rather than thinking about your infrastructure. And that, I think, in the long term is the right way of thinking about things.
How is that? We hear like, it's kind of a tried true, I think at this point, but that web companies, compared with maybe an average company in terms of the number of administrators they have looking over, these huge amounts of servers. Does that make it to the point where, you need just fewer operations personnel?
Absolutely, right? And you're really forced to do it because, Moore's law, makes 50% growth year over year not that scary, like from a technical perspective, because the disks are getting bigger and the memory, the RAM is getting cheaper, et cetera, et cetera. But you can't scale your organization by 50% every year and keep doing things the way you did. And you need to have sort of efficiency of scale where one person can handle more and more actual work. And that pushes you to go higher up sort of in the level of abstraction. That's why I said, I think for both developers and administrators, and with DevOps, this is converging, it's much more natural to think about an application than to think about VMs and administer VMs.
Yeah.
And that's one of the things that gets you to do more with less overhead.
Right. I mean, did Google ever, I mean, as server virtualization, this stuff was kind of coming around. I mean, was it ever a thought like, hey, we should look into this, or was the container approach always, and that sort of approach always the vision?
No, actually, these are both viable alternatives, and for our internal use case, since we control the entire stack, software stack, you're not forced to use virtualization. If, for an external use case, for the security reasons, because you need to run arbitrary OS and arbitrary libraries, et cetera, you're really more or less forced to use the VM case. Internally, a lot of our things are running, closer to the bare metal, because at such large scale, let's say search, right? There's really so many machines. If you really want to go for the last 10, 20, 30%, that's worth many millions of dollars. And virtualization does have some overhead, so you want to pick the right thing. And so internally, because we had really full control of the stack, we weren't forced that way, but we always looked at it seriously, and in our corp environment, we've been using it for a long time.
All right.
Right tool for the right situation.
All right. So this brings us back to, we were talking about Kubernetes, and, I'm kind of thinking about this. I mean, I don't know, maybe I'm, mischaracterizing this, but it kind of seems like, when Google released App Engine now in 2008, it seemed like kind of Google's way of saying, here's how we think about running this stuff. And, the platform stuff has had, mixed reviews and mixed traction. Right now you're doing Compute Engine. I mean, is this kind of is the container stuff kind of I don't say an end run, but a different way of saying that same thing, like reapproaching, here's how we think you should compute?
It's actually kind of the same, because in a way, what you want is have lots of flexibility, but at the same time, zero administrative overhead. And App Engine was really optimized for zero administrative overhead. We always used to joke, your only administrative action is to update your credit card every two years. And other than that, your app may grow by a factor of 10. We may move data centers. The infrastructure's upgrading. You don't need to do anything. But that came with a constraint in what you could use. It was a relatively vertical world. Even in that world, it's been hugely successful. Right? Like, we have giant applications on it. Snapchat, for example, runs on App Engine. Right? Bazillions of queries per second, et cetera, right? Works really, really well. What we're doing now though, is to say, hey, you want this kind of ease of use, but you want to have many more choices. So we have managed VMs where you can put Fortran in a VM, but you still get a lot of the management for free through the App Engine framework. And so really, it's a mix and match. Use the right tool for the right job. And even on the VM side, if you can avoid it, you would like to think about the details of your VM and administer each VM separately. You want to actually do as much of it sort of automatically. So I think the idea of automatic management is what's going to win sort of long term. And platform and infrastructure aren't really two opposites. They're really 2 points on a spectrum, and you as a user want to pick where in that spectrum you are. And you'd like to be to the right, because there it's easy, and you'd like to be to the left, because there it's very flexible. And ideally, we can make you get both at the same time.
All right. And the other thing Google announced recently that I thought was really interesting was this idea of kind of cross-geographic in terms of load balancing, right? I mean, that's another sort of, so let me just, again, back up, but I was curious what the thinking was behind launching Compute Engine and, getting into this space, right? And then getting into how do we actually start surfacing a lot of this stuff that we've been doing internally as a service?
It's really 2 parts. One is that it's very clear that over the next decade or two, workloads are going to move to the cloud. It's obviously the right thing from an economic perspective, from a functionality perspective, and it will be the obvious thing from a security and compliance perspective. So there's really no reason to be on-premise. And you're just arguing about the when versus the if, or at least that's my view of things. So given that, and given that we've actually done all of that work, we've lived in the cloud for 10 years internally at Google. It was a very natural decision to go and say, let's externalize our infrastructure, because this is a huge business, and we really have unique advantages there.
All right. Yeah, it does seem to be, as Compute Engine has kind of matured over the past, year, 2 years since it was first announced, you do start to see these things come around, right? Like these ideas. Because I think when people thought about cloud computing initially, there was this idea of kind of ephemeral stuff and workloads moving, and it just never exact same thing largely.
But I think that will be going away. So I think in the last, if you look at the velocity of, well, let's say the rate of innovation in the last 5 years, sort of in the public cloud, I think the next 5 years will be faster because it needs to be, right? The cloud needs to be much easier to use, much more scalable, right? Much more cost effective, et cetera, much more elastic. And much of the cloud in, 2019, hasn't been invented yet. But we'll absolutely, I think that's actually one of the exciting parts here.
Right. And you mentioned that workloads will need to move to the cloud for security compliance reasons. I think, the private cloud people would disagree maybe fairly vehemently about that. I mean, what is it? I mean, how do you see that playing out where, security compliance in the cloud becomes like a better, more insurable sort of thing then?
To me, that's actually similar to global load balancing, let's say. Why is it hard for you as a company to get it right? It's because it's actually hard. And why is it easier for us? It's not actually easier, but we had to solve it many years ago, and we had to solve it at scale. So I'd say our solution is actually really good. And so reusing a solution that's really been battle tested is a good thing. Security is the same thing. Many people obsess about, my data is inside my four walls, but if you read any news, you know that physical location is not what makes your security. And getting all the elements right in your entire security chain, from all the way from the end user to all the way into your encrypted storage, is hard. And if we can have more cookie cutter infrastructure and services that actually get these individual pieces to link up together without making accidental mistakes, that will increase your de facto security.
All right. I mean, is that scary? Like, if I say, well, I'm company X, no one's going to target me, but Google might be the, Google's like, I guess, a target, right? So the more it has.
Oh, but again, right? If you have a single key that protects everyone's data, that would be a bad design. And so if you can have a single break-in that compromises more than a relatively small compartmentalized things, then you're not doing security right. So I think, the reverse is true because we are a target for Google.com. It has nothing to do with our cloud. Everyone wants to get at our users' data. We have a huge security team and a very, 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 very good security team that basically no other company can afford, more or less. But for us, it makes perfect sense to do that because of our consumer business already. And it used to be that consumer business was lower ambition/requirements, whatever, than enterprise. That's no longer true, right? After Snowden, consumers want exactly the same, the highest grade security and privacy that they can get. And so our efforts there, I'd say, are very high in any kind of context, including the enterprise one. And as a beneficiary in our cloud, you benefit really from all that effort for free, basically.
All right. We have just a little brief amount of time, but just in closing, I mean, what's the thing, I guess, the biggest challenge that you see going forward? What's the next big, hurdle for Google to tackle from an infrastructure perspective?
I think there's new hurdles every month, and I think one of the great things is that it never stops. And so my job is, I've had the same job for 15 years more or less. It's never the same job. So that's really what makes it great.
All right, great. Well, thank you.
Thank you.